Our next speaker is Mr. Jose Alvarado. He is the technical advisor for AFOTEC Det 5. He's a senior test engineer and systems analyst at Edwards Air Force Base with over 33 years of developmental and operational test and evaluation experience. He's a Ph.D. candidate in the systems engineering doctorate program at Colorado State University with research interests in applying MBSE concepts to flight test engineering domain and implementing test process improvements through MBT. Jose holds a BS in electrical engineering from California State University, Fresno, and an MS in electrical engineering from California State University, Northridge. He will be presenting developing model-based test flight test scenarios.
It's a mouthful, isn't it? All righty. Well, thank you guys very much for being here. I do have one disclaimer that I want to do for this part. The particular presentation that I'm giving is part of my dissertation process, and it's the article that I ended up reading. So the views and everything that I'm going to be talking about is from my side of the fence. It's nothing on the AFOTEC side of the fence, although AFOTEC is part of the, we're trying to implement and figuring out what this whole digital engineering, digital twins, and all of that stuff is going on. So because this is part of the stuff that I'm doing for my school, of course, I'm using my school colors that we end up having, and the presentation comes from that point of view. Towards the end of the slides, I'll end up transitioning over to the AFOTEC side of the fence and kind of talking about what AFOTEC is trying to do and what we're trying to go in with this particular process. So with that, let's go ahead and get started here. There it is. Okay. Am I moving here?
Hit forward once on the computer and then
There it is. Okay. Forward arrow. No, I'm doing that. It's not allowing me to do that. Here it is. Okay. Come on. There it goes. All righty. Alrighty, so this particular presentation is going to focus on seeking and adapting novel ways to incorporate a long-standing structured process of flight testing into what we call the MBSE paradigm, which is model-based systems engineering. By leveraging tools and processes implemented in MBSE, the hope is to advance processes that we use within flight test planning by improving the understanding of for designers, testers, trying to streamline communications and the sharing of information and taking advantage of reuse and replanning to implement practices that kind of free the technical experts from being involved at the end of the process and more bringing them towards the forward portion of the process where we can influence the design process a little bit better and kind of talk about implement what the director of DOT&E was talking about, was trying to get those particular processes at the beginning and make testing and validation a little bit easier towards the end is my intent of what we have. So just to go through what we have right now, the current system that we end up using, of course, is a document-centric process in where we have a bunch of different groups that are doing different things that are involved in different processes, and they shuffle papers back and forth, whether it be a temp, whether it end up being requirements, specifications, CDDs and SCRs and all of this other fun stuff. And they all have to constantly go through modifications over and over again. And it's just a redo of paperwork. Versus if we end up going into a systems approach where we're doing a model-centric approach, usually what happens is everybody comes to the table and everybody is working on one model. So as one person ends up making an implementation on their particular process, it immediately propagates through the whole system and everybody is able to see it and take advantage of that particular change is what we're looking for. So what we're trying to do is to try to get these acquisition programs to benefit from integrating both the developmental and the operational T&E to include testers in the early design process as well as throughout the whole acquisition life cycle. Now, one of the things that I've been seeing and getting involved with stuff as we go along is buzzwords, digital engineering, MBSE, digital twins, all of that other fun stuff is the vocabulary that we end up having. Everybody has different understandings of it and what goes on. And one of the things that I want to put together, or we'll talk about really quickly, is the definitions of what I use and what I refer to when I talk about these particular things that we're looking for. So when we end up talking about the digital engineering strategy, the DoD defines digital engineering, of course, as the integrated digital approach that uses an authoritative source of systems and data as a continuum across disciplines to support life cycle activities from concept through disposal. Now, digital transformation is the integration of digital technology into all areas of business, fundamentally changing how you operate and deliver value to a particular customer. And this is where really a lot of people end up getting wrapped around the axle, as I like to call it, and where people think digital transformation means this grandiose plan that's going to save the world, Skynet's going to come in and we're all going to become slaves and all of that fun stuff. Digital transformation is just the process of really just going from using paper products to something that we can end up using and we can distribute widely and very, very quickly, as the definition implies. Now, Nkosi describes model-based systems engineering as that formalized application of modeling to support system requirements, design, analysis, verification, and validation activities, beginning at the conceptual design phase and continuing throughout the development and later into all of the life cycle processes that a system under test is going to go through. So as you can see, it incorporates a lot of the pieces from everything, as we call it, from the cradle to grave that we have for particular systems. Now, when we end up defining model-based testing, this particular one comes from the book that is kind of like the seminal work, if you will, from software model-based testing. One of the approaches that I ended up looking at was talking about, saying, flight test is a tried and true process that we've been doing, since technically right after the Wright brothers ended up doing their first flight. We've been doing test and evaluation. But the process that we have is a very, very, like I said, very, very document centric, very, very linear type of a process, if you will. What I ended up going into is saying, well, wait a minute, other people do testing, and where can we take other advantages and where can we come up with and look into other things that we can implement, innovative processes? Well, software testing does a lot of type of testing. So when I ended up looking into the process of where can I come up with new inspired ideas, I looked into model-based testing from a software perspective. So that's really where these two particular processes come with, where model-based testing uses this concept of taking behaviors and artifacts, if you will, to put them together in order to do their particular testing. Now, software testing does a lot of the automated side of the fence. Well, it's kind of hard to do automated testing for flight test. A pilot is not a robot and you can't program them to do the same thing over and over again. They like to poke holes in the sky and they always want to do something different every single time. So there's not a way to do that. So one of the things that I started looking into is what we call this model-driven test design. And the model-driven test design is what I kind of ended up focusing in on, because what it allows us to do is it allows us to take a series of tasks or a big testing task and break it up into smaller pieces, and we allows us to isolate those particular processes and then work on them one at a time. And then once we do that, we can take those particular processes, put them at a higher abstraction level, and then end up using mathematical engineering processes and different types of structures that we can then end up using that to validate the independency of that particular test, away from the actual artifact or anything that you actually need physically to get that process working. So once again, that goes back to that whole process of taking the expert from waiting until they have a physical article to test, bringing them all the way up to the front, so that way they can influence a design as they go along. Okay, now, one of the things that you also look when you start talking about testing are all the different types of software testing techniques. Now, software testing usually uses what they call the white box approach. Now, the white box approach is you basically know everything about the system. You know the code, you know how it works, you know how it behaves. So therefore, you are very, very familiar with what is going on. Now, flight test uses what we call the black box approach. And where the black box approach is you don't know nothing about the software. You don't know nothing about how the system behaves. All they do is hand you something and says, go and test it. Or as I like to say, try to break it is what we end up having. What we were looking for is there a way that we can kind of combine both of those pieces? Basically, software is on the white side of the fence, flight test is on the left-hand side of the black side of the fence. So there's a process that we call gray box testing. Now, gray box testing kind of is the best of both worlds, in where you do know how the system behaves or how the model ends up behaving, but you can take advantage of some of those processes to end up developing your test planning as you go along. Okay. Now, one of the things that you can also use is what we call coverage criteria, which is basically a set of conditions that rules that are imposed on a set of test requirements. And there's all kinds of different types of coverage criteria and they're all based on different types of data flows and what you're specifically looking for. Test coverage usually enhances the generation of comprehensive test cases based on the number of elements that you end up visiting within a particular diagram. And I'll go into a little bit more detail about how that ends up working for the particular process that I'm looking at. Now, the typical flight test approach follows this document-centric process, and where we have some kind of a test artifact, we end up this is the software side of the fence of what we have. So this would be the software model-based design type of a process where they have some kind of a test or an artifact. They develop some kind of a model. Based on that model, they create the test requirements, and then they end up going through, that's all up at the abstraction level. Once you end up defining all of your specifications and your test requirements, you can then go into the implementation level where you develop your test cases, your test plans, scripts, you go through the testing, and you end up figuring out whether you end up passing or failing. If we superimpose the flight test application process onto this, which is all of the little yellow boxes that we end up seeing, we can end up breaking up our particular process into the abstraction level, which would end up being the test design. And then we can take our test planning, test execution, and the test evaluation and implement it at the lower abstraction level that we have, with the particular arrows that we end up going back in, where when we end up getting into the test planning phase, if there are things that we need to refine or we find out that need to be revisited, we can always go back and try to either implement them in a different way or reuse them. So therefore, we can end up making flight tests more efficient as we go along. So the process that we came up with, or the innovative test scenario generation process that I ended up using follows along the model-based systems engineering process, in where you end up using the different diagrams that are created within the SysML system, which is the systems modeling language is what SysML stands for, and where you can end up using use cases to determine the number of paths based on the decision criteria that I talked about previously in the previous slide. And then those will fall into the activity diagrams, where you end up confirming the paths. You determine if there's any alternate paths that you end up having, and you can identify the resources and the activities that you need for those particular scenarios. And then you can also use the sequence diagrams to further identify the signals that required by each particular activity, and also to verify that you have seen all of the particular paths that you end up having. And then once all of these three diagrams are used in conjunction, you can actually generate a test scenario and the detailed test procedures that you would need to solve for that particular test scenario. So here's a typical case, not a case scenario, but a use case that is based on the combat search and rescue locator, as we in AFOTEC, everybody commonly knows it as a CSARO. And this is a particular system. It's a fictitious system that we end up using in AFOTEC to train everybody on how we do flight testing and how we do operational test. So I ended up using that system because that's what everybody is familiar in AFOTEC with. And it would be a good way for me to implement this particular process and to pass that information and to get people to understand what's going on. So as you can see, this particular use case ends up having different types of paths, and it has different people that are involved, which are all the outside boxes. And then all of the stuff that's inside are all the different types of scenarios or the things that need to be implemented by this particular process. So, and that's kind of what this slide ends up happening. I'm horrible at this. I always end up talking ahead of myself, and I end up forgetting to flip my slides. But that's kind of basically what I was talking about. And like it says in that last bullet, it makes a good benchmark for applying this particular gray box approach that I ended up speaking to in the previous one that we have. Now, when we end up taking this particular use case, I end up then following into the next diagram, which is what we call the activity diagram. Now, the activity diagram basically shows the behavior of the particular system of what we're doing. So what I am doing is, instead of looking at the actual box and how the box works and all of the inputs and the outputs, as I like to call them, the gazettas and the gazaudas that end up going with the particular box, what I've done is I've taken that concept and brought it up one level of abstraction higher, and I'm looking at the behaviors of the particular system. And by looking at the behaviors, I can end up using the activity diagram to give me those particular those inputs that I need. So as you can see, for the CSARL system, this is the typical flow of what you would end up seeing. And as you go through this particular process, you end up seeing that there are 3 individual paths that you can go through, or 3 different types of cases or case scenarios that go along. And I know it's kind of like an eye chart, but as you can kind of see, you have a solid red line, you have the dotted red line, dotted blue line, and the dotted green line. So the dotted lines are the 3 typical scenarios that this particular system and what I'll be talking about goes on for this process. So when we end up looking at this and we end up applying the criteria that I referred to, we end up coming up with these 3 particular scenarios. Now, these particular scenarios will go through a process flow. You end up having the flows that you end up getting is, of course, the basic flow that goes through the whole system from the end to from the beginning to the end. You can have alternate flows in where you end up you deviate from a particular path, but then you end up coming back to the main path, and then you finish off what you have. And then, of course, there's the exceptional flow path, in where you deviate from the path and then it ends or it terminates and it never comes back to the main branch that we have. And as you can see here, test scenario number 1 falls into the basic flow. Scenario number 2 is the alternate flow program. And then scenario number 3 is the one that gives us the exceptional flow that we have. We'll get into detail about what those are.
That's the blue one, and that's the green one.
Correct. Yes. So it would be the red, blue, and then green as far as the dotted lines are concerned. Thank you very much. So when we end up taking this process and we end up running these through the use case diagram and the activity diagram, what we end up looking for is one of the things I didn't show in here is the sequence diagram, because the sequence diagram had a lot more detail in it, and it was just a real horrible eye chart, so I didn't include it in it. But once we put those 3 particular pieces, what happens is you end up developing the 3 basic test scenarios that you would have to implement or to test those particular scenarios that you have. And you see the first one is test scenario 1, and then 2 is on the upper right-hand corner, and yeah, right-hand corner for you guys. And then the lower left right-hand corner is the one for test scenario number 3. Or do I have them backwards? Oh, I mislabeled it. This should say 3 on that particular one. So the lower right-hand corner should say test scenario number 3, not number 2 of what we have, which is the alternate one that ends up ending the process. And that particular scenario happens to be in the case of our poor pilot that's down. If he ends up he's in dire straits and he's going to get captured by the enemy. He wants to destroy the system so they don't end up getting to the actual box and all the encryption and all of that fun stuff that we have. So he has to destroy the box, and that is the process that he ends up going through what we have. Okay, so This particular case study allows us to compare the system between document-centric and model-centric processes as far as how we can go from using models to develop our particular processes. The results of this model-based testing scenario shows that the methods is effective in creating detailed test scenarios, and we can use it for the generation of detailed test plans, or what we end up calling DTPs, for us to do testing of what we have. And then, of course, similarly, in the output between the model-based testing scenario approach and the document-centric approach, it provides confidence that the both processes can generate similar documentation for testing systems under test. So when we end up looking at, by the time we get through all these detailed procedures, what you end up seeing is on the left-hand side is the actual table of contents from the document that we end up using in AFOTEC, versus the right-hand side is the different detailed procedures that I ended up developing out of the model side of the fence that we have. And as you can see, all the particular pieces that are in the detailed test plan that we have, or test procedures, I'm sorry, also end up falling into the process for the model-based side of the fence. So we can see that the two systems, yea, verily, are similar and produce the same type of output that we end up having. So as far as the conclusion is, we can say that the CSARL case study as an example shows that this novel, innovative gray box testing scenario can create the required documents at the same fidelity as the document-centric process that we end up having. The case study further shows the potential for efficient and valid use of SysML models for test planning and design within an MBSE construct, applying the MDTD process that we end up borrowing from the software side of the fence. Using MBSE and gray box testing, we can end up transitioning into this digital transformation, and we can end up constituting it as a stride towards modernizing testing methodologies and enhancing systems evaluations and validation. The particular case study here exemplifies how adopting MBSE methods aids in the formulation of test scenarios, how we can contribute to the comprehensive test planning for assessing a system's capability. And then, of course, how do we end up applying this? Well, one of the things we have to do is we have to embrace the paradigm and the shift towards MBSE in the flight test community for us to use it in terms of flight test planning and end up making progress towards implementing the DoD's defense digital engineering strategy that ended up coming out. I think it was 2018 is the document that we have for that process. Now, that is kind of basically what what my novel concept was in terms of my schooling was concerned. One of the things that we, from the AFOTEC perspective, so now that I'm taking off my academic hat, I end up putting my work hat on. This is kind of what we're looking for, or what we have in terms of what we're doing for AFOTEC. The two main pieces that we're looking at in terms of my conclusions that we have is embracing this particular paradigm shift towards the end MBSE, using MBSE in flight testing. What is AFOTEC trying to do? Well, we basically have put together a consortium, if you will, of all of our detachments, and where we meet on a biweekly basis to end up talking about how we implementing this and how we end up creating, or how we'll end up using this particular process for future test plans and future systems that are coming on. Because that's where everything is going. One of the mandates that the DoD says is all new acquisition programs will end up using a digital engineering construct, and everybody will be on that particular process. Now, the other thing that we have is the potential for efficient and valid use of System S models for test planning design and adopting MBSE methods to contribute to the comprehensive development of flight test planning for assessing the system's capabilities. Of course, new acquisition programs that require the contractors to use the SysML programs or SysML diagrams, like I stated before. We in AFOTEC, we need to work with those particular with the particular program officers and the contractors to integrate all of our AFOTEC test planning processes and into those SysML models, and then use them for our particular purposes that we end up having.
So can I jump in on that one, right? So in the United, So I gotta start doing that. Brian Kelly, I'm the Chief Data and Analytics Officer at the US Army ATEC. So on the Army side of the house, it's not enough, like in my world, it's not enough to say DODAF or UAF profile shall be followed doing systems engineering.
Correct.
There needs to be another layer of that onion peel that's defining, this is the way we represent PNT receivers. This is how we represent EO sensors, IR sensors, right? Weapon systems.
Correct.
Because if you don't define those systems engineering standards to that level for our domain, you're gonna look at some vehicle in the Air Force, another vehicle in the Air Force with common components, but the two are gonna be skinned completely different. And a lot of this breaks down at that point in time. So is Air Force working in that systems engineering world?
Yes and no. Let's put it this way. The answer is yes, we are working on it officially. I probably would not, as an official Air Force perspective, probably no. We have there's a particular group from the 96th, I believe. They end up, they've put together what they call the weapons GRA, and they are basically creating a reference architecture, or what we call a GRA, that tries to model that particular process. And we're using it as a template, if you will, where both contractors, SPOs, and then all the test organizations end up feeding all of this information, basically a systems of systems process, that we can end up, each one of us develop our own reference architecture that we can use as a template for that particular purpose. One of the things that we and part of our AFOTEC MBSE OT is developing that particular GRA that we're working on. Right now, we're working on rules of engagement and then how we end up doing that particular process. So yeah, we are looking at that process right now. Do we have anything official? The weapons GRA is the farthest that they've gone to that we have. And then we're just following suit with those particular people.
Yes.
All righty. Well, with that, good segue. You ended up giving me my questions. I ended up starting before I ended up slipping my slides that we end up having here. So any other questions?
I guess maybe a comment question, or you can to kind of dovetail what you just outlined. But I don't know that your approach necessarily dictates that there be a digital twin or digital model of the system under test, more so that this process can be done digitally. The test process can be done digitally.
Correct. Yes, yeah, and that is correct. My particular process and what I'm talking about, what I'm proposing is that we can use it for any type of process, whether it end up being a document-centric systems that are right now that we have going on, or any future type system that we have.
But I think the point being, right, you got this systems engineering hinge that's being leveraged and been trying to be leveraged for decades or decade plus. You can add this layer of test and evaluation in that architecture. You can add this layer of cybersecurity in the architecture. You can add different layers on top of this existing construct to benefit, right? And that's
Yes,
kind of
absolutely, yeah.
the main piece that I think people might be missing is.
Correct. And that's kind of, and that's where the weapons GRA is trying to go to, and that whole systems of systems approach, and where each particular person or each particular entity will end up creating their own reference architecture that you end up incorporating. So depending on which layers you need, you end up putting those particular layers in place for your particular system that you're working on, is what we're looking for. And we're hoping that at one particular point in time, right now we're looking at it just at the Air Force level, but hopefully I know the Army has done quite a bit of work. And I know that we have a couple of other higher consortiums, if you will. I think it's a monthly basis where a lot of other people, the Air Force Flight Test Center from the developmental side is getting together with both the Army and the Navy and talking about those particular processes as well. So hope that answers the question of what we got. Any other questions? Yes, ma'am.
Why SysML is the MBSE modeling language? I'm just curious. And like, have you received any pushback from people who want to use Rhapsody or something different?
Well, SysML itself is the basis, is the basics software, if you will. It's kind of like using Python, MATLAB, that kind of a process that we have. From the systems engineering point of view and the NCOSI side of the fence, that is the architecture that they created, and it's called the SysML UML about 2.0 is what they have. And those are what defines the individual diagrams that you end up using, and then all of the different boxes and arrows and everything that defines how things are put together. Now, how you use that particular tool, it depends on what you want, whether you use Rhapsody, Cameo, or whatever. That's whether you want to use a Mac versus the PC versus Android or something along those lines. But SysML is the bottom foundation that you have.
UML was the parent, right?
Yep.
And there's multiple MLs under that, one of them being SysML. And then for us in the DoD, there's DODAF and UAF.
And UAF,
And
right?
that's so DoD architecture framework and unified architecture framework. Those are profiles associated with how to model within the DoD, but to me, it just doesn't go the distance. There's another layer under that, that reference architecture.
Right, yes.
Of common components that has to be defined for us to use. And then all the clients, like you mentioned.
Correct. So it's, okay,
Right, in the interest of time, we'll sit out there, but sure that there was there are additional questions.
thank you very much. I appreciate it.